Founded more than 70 years ago to provide filtration, purification and separation solutions to the aeronautical industry, Pall Corporation now has got two divisions, Pall Industrial and Pall Life Sciences. Within Life Sciences, the Pall Biotech business unit is a leading supplier of traditional, single-use, continuous and hybrid equipment to support all types of drug manufacturers, from R&D phases right through to cGMP production. We offer robust, reliable manufacturing equipment and consumables, and we complement these technologies with exceptional development and application support, and also industry-leading scalable customer service for the life of your process. So our approaches are based on three core technologies. So starting with the bioreactor, the continuous harvest. We have a technology based on acoustic wave separation technology, which enables us to remove cells and cell debris from a cell culture.
AWS, or acoustic wave separations, utilizes a three-dimensional acoustic wave, and as we pass a suspension or cell culture suspension through this acoustic wave, the energy of that wave drives these cells to clump. These cells then will fall out of solution, allowing us to achieve separation or clarification of our feed stream harvest.
In order to do continuous chromatography, we have an approach to do multi-column chromatography using a single-use valve cassette, which is technology that is owned by Pall. And this enables us to process at laboratory scale up to 16 chromatography columns, and at production scale up to 8 chromatography columns all at once.
Multi-column chromatography enables us to replace the large columns that are used in batch operation, cycling much smaller columns through the chromatography steps, thus enabling us to process the same harvest volume using much smaller volumes of sorbent. Well, one of the big drivers associated with continuous operation is going to be obviously the reduction in the amount of sorbent that's required to process a given volume. By enabling us to reduce the size of our columns and the footprint of our systems, we can enable the use of single-use systems, as well as improve the safety of the manufacturing facility.
And then the final core technology is continuous filtration. And we have a range of products based on single-pass tangential flow filtration, which again we have an exclusive position on, and that enables us to do many of the concentration and dye filtration operations in a continuous manner.
Dye filtration is a required step in most biological drug manufacturing processes. It can be used in various steps in the process, but particularly to get the drug product in the final formulation that's required for filling. Traditionally, dye filtration is performed using tangential flow filtration, or TFF technology. With TFF, a feed pump is used to deliver the process fluid from a feed tank to the filtration device, which is then recirculated back to the feed tank. As the process fluid is being continuously recirculated through the system, fresh buffer is being added to the feed tank to replace the permeate buffer that's being removed. Conventional TFF requires constant recirculation through the system. It makes it somewhat unsuitable for continuous processing. Also, it doesn't operate at a steady state, so the concentration is changing over time throughout the process. The Cadence Inline Dye Filtration Device, or ILDF, is a new technology that allows for truly single-pass continuous dye filtration. With this patented technology that Pall has exclusive rights to, dye filtration is enabled through staging that allows for repeated dilution and concentration cycles within a single modular format without the need for recirculation. And because it operates at a steady state, this is what really makes it ideal for continuous processing.
So having got the building blocks, all we now do is take exactly the same processes that you would have done in batch. In other words, the same cell culture media, the same chromatographic media, the same membranes, the same buffers, but we just do them in a slightly different way. Therefore, the challenge from going to batch to continuous shouldn't be very difficult.